Alright, we are finishing 11.4. That'll be the last thing that is on your quiz next time. Okay, so your quiz is over 11.1 to 11.4. Okay, 11.1 was all vocab. 11.2 was the angles inside. Okay, 11.3 was angles inside and outside. So that encompassed the interior and exterior. 11.2 was the inscribed and central angle. And then 11.4 is going to be chords. Okay, who remembers from 11.1 what a chord is?
A segment that has both endpoints on the circle.
Very good. A segment with both endpoints on the circle. Okay, does it go through the center?
Not necessarily.
Not necessarily, but it can, because the diameter is also a chord. Okay, but a chord has both endpoints on the circle. Okay, so we are going to start with property number 1. And property 1 states that if two chords are congruent, then the two associated arcs and the two central angles will be congruent. Okay, and associated arcs just are like, if this is chord FC, then the arc associated it would be arc FC. So it contains the same points. Okay, has the same endpoint as the arc. If two arcs are congruent, then the chords associated with those arcs are congruent. Okay, so it's just the converse. So if two of the arcs are congruent, then the two chords associated would be congruent. Okay, so looking at example number 1, M is the center. Okay, the measure of major arc CDE is 220 degrees. Okay, if CDE is 220, what is the measure of CD? 100. Okay, we need to figure out X, which is the length of this chord over here. Okay, if I draw my central angles in, what would be the measure of angle CMF? What would be the measure of angle CMF? 70 degrees, because the central angle is the same as the minor arc. Okay, we are missing one other arc, which is arc EF. How do we figure out arc EF? Very good. Add everything and subtract from 360. So make that happen. What is it? 70? Okay, so we have arc EF is 70 and arc FC is 70. So according to our property, what does that tell you about chord CF? It equals 1. Okay, because by our property, if two chords are congruent, or better yet, if two arcs are congruent, then the chords associated with those arcs are congruent. Okay, so X would equal 1 because both of these arcs are 70 degrees. I just asked about that central angle to see if you knew and remembered. Yes?
In that second definition, if you know the two arcs are congruent, then do you know that the two angles are congruent too?
Yes, because they're central. Okay, 2. Okay, what would be left in arc EF? 55 degrees, so you have 2 congruent arcs, which tells you that x equals 8. Questions on property 1. Okay, that's the easy one. Property 2, if a diameter is perpendicular to a chord, then the diameter bisects the chord and its arc. So if a diameter is perpendicular to a chord, then the diameter bisects the chord and its arc. Okay, so if M is the center, AM equals 9, find X. So if AM equals 9, find X. Any ideas on how we can solve? Okay, what if I give you a hint and draw that? Trig.
Oh, that's so, I was thinking.
Okay, what is the length of the line that I just drew?
Hypotenuse.
What's the length of that line that I just drew?
9.
9, because it's also a radius. Comes from the center and touches the outside of the circle.
Whoa! That was cool.
Okay, what else do we know?
30, 60, 90. Is that not 5 or 4 points? It's 5 seconds. Right? I don't know. Oh wait, actually, I don't have enough.
Okay, what does this arc tell you? What does this arc tell you?
That the 60.
Very good. So this angle up here has to be 60 degrees because it's the central angle that opens up to that arc.
I'm not crazy.
So that creates, like Miranda said, a 30, 60, 90 triangle. Okay, so I'm going to draw it out here so that it's bigger.
You're so kind.
Okay, so what rule is associated with the 9 for a 30, 60, 90? 2x. So what does that make x equal? 4.5, and then across from 60 would be what? X radical 3, which is what? 4.5 radical 3. Okay, so your 30, 60, 90 rules are coming back. Okay, so what does x equal? 4.5 radical 3. Guys, there's way too many side conversations happening. Questions? Okay. 4, M is the center. AB is 30. Find SD. Okay, so what should I label what? AB is 30. AM is... Okay. Then what?
Can we draw a line FM?
Draw a line FM, and FM equals what? 15. Now what? Pythagorean theorem to get FE. So you have x squared plus 6 squared equals 15 squared. x squared plus 36 equals 225. X squared equals 189. So what does x equal? Is that rounded?
Yeah.
Okay. Okay, so how do we find FD? Double it. Do not forget to double it. Okay, remember that it is bisected. Okay, so 13.75 times 2, and you get
27.5.
very good. The length of FD is 27.5 units. Questions about the diameter bisecting a chord if it's perpendicular? Nothing? Okay. So on those, you're always going to most likely need to draw another radius so that you can form a right triangle. It's not going to be obvious. Okay, 9 times out of 10, you're going to have to draw your own. Okay, next property. Property number 3. If two chords are congruent, then they are equidistant from the center. And then the converse, if two chords are equidistant from the center, then they are congruent. Okay. If CE equals 8, find AB. How do you know it's 16? How do you know that ED equals 8?
Why not? What's the full chord? Wait, but do you make a triangle? Triangle C and B.
Pictures of the project to turn it in.
Oh, you make triangle MDE.
We have to take pictures
You can do that.
of our project to
No,
turn it in. I kind of need my vote for that.
I'm at this point figuring things to there.
I'm sure there's going to be other devices. Not everybody has a phone.
Well, I mean, no.
If your teacher emails me, I'll give it back.
Okay.
Okay, but right now I'm teaching.
Alright.
Thanks.
Oh, because it's
Okay. Very good. If the diameter is perpendicular to a chord, just like the property up here. Okay. Look at the property up here. It's the same thing. You can use multiple properties in one. That's how you know that ED is 8. Okay? Because I could draw in a diameter. Okay? However, our new property says that if they're equidistant from the center, which is where these 4s come in. Because they're equidistant from the center is why AB is congruent to CD. But you had to use property 2 in order to get CD.
And you know
So,
that CE is equal to ED because of the second, second property?
yes.
Right.
So what does AB equal? 16.
You were right. Yeah, you were right.
Okay, for 6, M is the center. Okay, we've got equidistant, so you know CD again is congruent to AB. If AB equals 18, what is DE? 9. Questions on 5 and 6? Okay, the next one you have to write a lot. Pay attention. Segment chord theorem. Okay, I'm going to draw a little picture and then I'll write words. Okay, you have segment A, segment B, segment C, segment D. Okay, the segment chord theorem says that A times B equals C times D. So A times B equals C times D. Okay, so part of a chord times part of a chord equals part of the other chord times the other part. Okay, so in words, it is if two chords intersect in a circle, then the product of the lengths of segments of one chord is equal to the product of the lengths of segments of the other chord. So in short, part times part of one chord equals part times part of the other chord. That's it. So A times B equals C times D. That's what you just wrote in words. Okay, so all work needs to be shown, blah, blah, blah. Figures are not necessarily drawn to scale. Find X and or Y for each of the following. Okay, so for number 1, how would you set it up? X squared equals 4 times 9, which is, so X equals, okay, and then go back and make sure that it's right. So if I put in 6, 4 times 9 is 36, 6 times 6 is 36, so we're good. Okay, number 2 has 2 secants drawn, so just pretend that those are 2 chords. Okay, because they do have points that lie on the circle. So just ignore the other parts. Okay, how would you set that one up? 5 times 6 equals 4 times y. So 30 equals 4y. So y equals 7.5. Yay, fractions! 3. Turn them into improper fractions. That's probably your best bet. Okay, so 2 1/4 of the improper fraction is 9/4 times 5 1/3 equals x times 4 1/2 is 9 1/2. Okay, 9/4 times 16/3. You can do some cross canceling. So you're. If you can like reduce it, it's like 9/3 reduces to 3/1. Okay. 16/4 reduces to what? 4/1. and then you can multiply numerator times numerator, denominator times denominator. It just helps so that you're not dealing with huge numbers.
I like that.
So you have 12 equals 9 halves is 4.5x. Now I would use a decimal just to keep it simple. And then divide. And so what does x equal? 2 2/3. And as an improper fraction, that's what? 8/3. If it's given in fractions, leave it in fractions. And you can leave it as either one. Okay. Ooh, yay, number 4. Okay, it's kind of like was it 10 and 12 of the notes last time? Okay. One part is obviously 4 times 5. What is the other part?
X times 12 minus X.
Very good. X and 12 minus X. Okay, so you have 20 equals 12x minus x squared. Okay, bring everything to one side, and I would make sure my x squared term is positive, so I'm going to bring everything to the left. So I have x squared minus 12x plus 20 equals 0.
Isn't it minus 20? Oh, wait.
I brought everything to the left. Okay, what are my two factors of 20 that is going to add and give me negative 12? Negative 10 and negative 2. Are they both going to be negative? Yes. Okay, so what are your potential x values? 2 or 10, but you need to make sure that they both work. Okay, if it is 2, what would be my two pieces of my chord? If x was 2, what would be my two pieces? 2 and 10. 2 times 10 is 20. 4 times 5 is 20. So we're good. If x is 10, what would be my two pieces? 10 and 2. So they both still work. 20 and 20. Okay, so you want to always plug them in and make sure they work. Okay, how do you do number 5? 5x times 6x equals 10 times 12. 5x times 6x is 30x squared equals 120. Divide by 30. So x squared equals 4.
Wait, 4. Sorry.
And x equals 2. Questions on the segment chord theorem? No? Okay. ACB is a semicircle. CD is perpendicular to AB. Find each of the following. If AD equals 9 and DB equals 4, what would be the length of CD? CD. How do you know? Why are you getting the divided by 2 thing?
Could you do trig? No. Oh my
Technically, yes. It would work. Raj isn't crazy. It would work. Because I can make 2 right triangles. And this would be labeled as x. It would work, but not what I'm looking for. What if I do this? Ooh, that's going to be a really bad circle.
Oh wow, she even had to get out the way now. We love her perfectionist.
Okay, so what if I were to draw that? Then what?
Properties.
What properties?
I don't know. Give me a second. Well, the diameter. Oh, 9 times 4 equals. Oh. Not that one. Where? I'm trying to figure out what it is.
9 times 4 equals x times 13 minus 6.
Where are you getting 13? Who says that those are congruent?
Wait, what?
They're not going through the center. What is?
You're on the right track, but I'm waiting for somebody to do the other piece. 9 times 4 equals x squared, because these are going to be congruent.
They are?
Yes, because AB is the diameter and it's bisecting the chord. So 36 equals x squared, so x equals, wow.
We're just making leaps.
Okay, try 7 on your own. You're going to have to relabel your picture, so hopefully use pencil. Or draw a new one.
The diameter is 80. CB, like the segment, like not the arc, right?
Right.
Okay. Oh wait,
90 seconds.
Oh wait, okay. Oh shit, I'm late for that. Oh, and then you make that piece X, and then you go
The two-step problem. You cannot figure out CB in one step.
Oh man. I like those little ones.
Do we get an improper fraction?
As your answer for CB?
Yeah.
Yeah. You'll get like a rounded answer. Not. I don't think it's an improper fraction.
I kind of
Could be.
math and made it one.
Oh, okay.
Do you want me to put the improper fraction or the density?
I have a decimal, so do that just so that you can compare it easier. Okay, what did you get for the little piece? DB.
2.
2, and then you do what?
What am I calling? Oh, I'm solving for
Pythagorean theorem to get segment CB. So 8 squared plus 2 squared.
I got it. Can I take it, Coach?
Because 32 times x equals 8 times 8. So 32x equals 64. X equals 2. That's to get this piece in order to do Pythagorean theorem. So 64 plus 4 equals x squared. 68 equals x squared. So what does x equal? Or CB? 8.25. Questions on 7. Your quiz is probably 50% chords. So if you have questions, you need to ask.
Clarification. When you draw that triangle, the line and the curve are the same, right?
No line and the curve, no.
Wait. Because it's not asking for curve, Stevie, it's asking for...
Remember, if it was asking for the arc, it would have had arc. Notation, children.
Well, it's a good thing I asked them. Right. It's just understood that it's segment.
Technically, if it just has CV, it's segment. It doesn't have to have the bar. Okay, last one. Do 8.
I'm going to get the art. I believe in you. Whoever says you're going to get it.
Get going. Shh. Okay, what are your potential values for AD and DB?
16 and 9.
16 and 9. Okay, it depends which one you labeled X and which one you labeled 25 minus X. So you might have 9 here and 16 here. Both of your X values work, and when you plug them both in, you just get the opposite. Okay, so technically AD could be 16 or AD could be 9. And then the same thing with DB because both X values work.
Would it depend on if that circle is like on scale?
Yeah. Which one you would label the bigger side? Yeah.
Right.
Specified? Or we have to like write both answers?
You would write both answers.
So it would be like 16.
Or chances are they'll just ask for A, B instead of parts, so that way it won't matter, if that makes sense. Okay, flip back to the front real quick. Okay, now that we did that segment chord property, Ms. Heck has actually pointed this out, which is pretty cool. You can use this segment chord property on problems like these. Okay, and the reason being is you know this is 9, you know this piece is 9, and then this would be X and X. So 9 times 9 equals X squared. And then the same thing for 4. Okay, so you could use 2 different methods to solve the problem.
And that's rather than drawing a triangle?
Hmm?
That's rather than drawing a triangle?
Right, but you'll see on your homework there's like more intense ones. So you'll want to draw your triangle. And I'll go over that homework problem in a second. But turn to your cheat sheet so that we can fill that out. Okay, so let's start with 11.2. Okay, 11.2. We started with what we called central angles and inscribed angles. Okay, remember your central angle has to have a vertex at the center. Okay, and your central angle has the same measure of the intercepted arc. So central angle is equal to measure of intercepted arc. Okay, then we talked about an inscribed angle. See how good you can get at drawing circles by the end of this. Okay, your inscribed angle has a vertex on the outside, or the edge of your circle. And it is 1/2 of the intercepted arc. Then we talked about a tangent chord angle. it equals 1/2 the measure of the intercepted arc as well. Are we recalling all this so far? Okay. Then we went to an exterior angle. And remember, if you're outside the circle, it means you don't fit in, so you're being removed from the equation, subtracted. Oh, I can't spell, and it was really looking pretty. Oh, man. I hate it when that happens. Differ. I think I still spelled it wrong. Is there 2 F's?
Yeah, that's right.
Okay. Thanks, guys. Okay. Exterior angle, you're taking the difference of your intercepted arcs. Okay, so remember, intercepted arc number 1, intercepted arc number 2, and you are subtracting them. So I'm going to label this arc AB and arc CD so that we can write an equation. So, it's arc AB minus arc CD divided by 2, and that equals X. Okay, you always do the one farthest away first. So this one farthest away minus the closer one equals X. So you kind of work like backwards. Okay? Then, oops. Okay, you have your interior angle. Okay, interior equals sum. Okay, so if I have X here, these two are my intercepted arcs because I want to make sure I have the angle that is associated with X, or the arc, sorry, that's associated with X, and then the one directly across from it. So I have arc AB plus arc CD divided by 2 equals X. Is this helping so far? Okay.
Wait, so we divided by 2 is not crossing the center of the circle?
Right. The center has nothing to do with this.
No, because it's not crossing the center, is that why we divide by 2?
No, it's just part of the equation. It's like a formula. Oh, are you saying why that's not a central angle? Like AB doesn't equal X because it's not in the middle.
Yeah.
Yes. Yes. Okay, can anybody think of anything else? That's everything leading up to today, right? Is there anything else we need to add to our... I think I got them all. Alright, now we're going to add our chord scenarios. Ooh, I need a new paper. It's going to be ugly. Okay. Our chords, let's start with the easy one. It's segment chord theorem. A times B equals C times D. Okay, then we have if these are congruent, then the two chords are congruent. I'll give everything a point. So, if FM is equal to ME, then AB is equal to CD. So if the chords are equidistant from the center, then the two chords are congruent. Does that make sense? Mm-hmm. Okay. Okay. The next one's going to be hard to explain, I feel like. Diameter bisecting the chord. The diameter. Okay, so if the diameter is perpendicular to a chord, okay, then it bisects the chord and the arc. So, let's see, how do I write this? So, if angle MEF equals 90 degrees, then FE is equal to ED. So then these two pieces are congruent. Hint, draw right triangles. And the last one. If these two chords are congruent, these two arcs are also congruent. So let's write that. If AB is equal to BC, then arc AB is equal to arc BC. And the converse is true too. So if arc AB is equal to arc BC, then chord AB is congruent to BC. Okay, so that's a good little cheat sheet to use. Go study for your quiz.
Wait, so is AB equal to